Hey everyone, welcome back to ETS21 Day 2. And I'm Laurel Morris with Zpryme. We're diving into a budding love, the utility-automotive industry relationship, with three thought leaders, Karl, Arlen, and Rob. So let's start off with quick introductions from you all. Arlen, could you please kick us off with your introduction?
Sure. Thanks, Laurel. And you can go ahead and pop my slide if you want to. So hi, everyone. It is great to be here, although I wish we were all together in person in Austin rather than virtually. And for those of you who are looking at my head, I do not have a halo. That's just a lighting effect from my house. So I'm joining you today on a beautiful fall day here in Sacramento. So I'm Arlen Orchard. I'm the retired CEO of SMUD, and currently I'm the chair of the California Mobility Center, which is a collaborative focused on accelerating the commercialization of new clean mobility solutions and getting them into the hands of end users. So before I get into the specifics of what the CMC does, let me start with an origin story of why the CMC exists. So big shout out to SMUD, who really drove the existence of the CMC, and to our founding partners, Sacramento State University, University of California, Davis, the Greater Sacramento Economic Council, the City of Sacramento, Intertech Capital, and PIM Motion out of Germany, which helped make the CMC a reality. So we recognize that a critical part of transforming the transportation sector and accelerating the transition to new non-carbon solutions was really understanding the cross-sector interdependency of utilities, auto companies, auto suppliers, regulators, tech companies, startups, and academia, and probably a few others. And we all play a critical role in this transformation, but big surprise for everyone, let's face it, sometimes there is a tendency for each of us to operate in our own silos. And silos just won't work because the clean transportation ecosystem is way more complicated than the carbon-based system. So we recognized that we needed to create a platform, an ecosystem where all of these different players had the opportunity to hang out together, to learn and collaborate. And that really is the vision of the CMC, to recognize that intersectionality of all these different players and create a space to optimize and, importantly, accelerate the commercial success of clean transportation solutions. So the CMC opened its doors in March of this year. Yes, during a pandemic, our timing couldn't have been better. Anyway, and as I said earlier, we're a cross-sector industry-led ecosystem made up of members, clients, and preferred service providers. And I'll touch on what each of those categories is. So our members are global industry leaders, including OEMs, tier one auto suppliers, utilities, tech companies, fleet owners and operators, universities, and venture capital funds. Our clients are the early stage mobility related companies in the areas of autonomy, electrification, connected mobility, shared and smart mobility, and charging and fueling infrastructure. I think I got the whole list. And our preferred service providers are best-in-class resources that are there to support our clients' success. So including in the areas of things like digital tech, testing and validation, market entry support, workforce development, advanced manufacturing, demonstrations and deployment, regulatory compliance is another one, and then equity and grant financing, and I probably left out a couple of them. So in all of that, we've created what I think is a really exciting ecosystem that is really focused on deployment and identifying and removing barriers for all the players in the ecosystem. We're providing a cross-industry collaboration geared to creating optimized solutions. So we're taking into consideration the needs of all the players in the system as we move forward. And we've created a platform to sync industry incumbents with their years of experience and expertise with early stage innovation companies who are pushing the boundaries of future mobility solutions. So as I said, we opened the doors in March. We are already working with our first group of clients. It's going well. It's really exciting, but we're a startup also. So as we move forward through this process, we are learning a lot and we're iterating to improve what we do every day. And I would urge all of you to check us out at the CaliforniaMobilityCenter.org, and I'll stop there.
Thank you, Arlen. I'm sure the audience is very eager to hear more about what you're doing, especially since it's just started this year. So Karl, could you start us off next with your introduction?
Certainly. If you can pull up the first slide there, that's kind of my contact info. I was going to end on the last slide and back one more. So I'm just glad to be on the Budding Love panel. I love this panel here and the organization they work with. Laurel, I love your Austin Energy, electric greater than gas shirt. And I just love the team here in Austin, the Electric Vehicles Emerging Technologies team. We're celebrating our 10-year anniversary together of EV stuff in the Austin community. And you're just seeing, you know, a lot of the smiling faces there, past and present. So any project I talk about is all reflective of their work and their project leadership. Next slide. And so our portfolio strategy is what we call the 5 pillars. And we have over 25 initiatives. You're seeing visuals of a few right there that cross charging infrastructure. So whether it's unlimited charging at 1,200 charging ports for $417 a month public charging, or our more recent DC fast fleet, it's affordability and equity programs to include EVs for everyone. And that's everything from excuse me, electric bikes, and recently launched education training and free helmets for HACA residents here in Austin. So for $5 a month, $5 a year, access to the new Cap Metro electric bike transit system. Working on fleets, both with electrifying Cap Metro, 12 buses and growing, as well as walking the talk and our own city fleet. We are on track for batch 1 is 331 EVs. Not only will there be emission savings, but on track to get $3.5 million in actual cost savings back to the city. We're currently at 255 EVs there. We do a lot in outreach and education. We have the award-winning EVs for Schools program, which if you're interested in having a 6th through 12th awesome online curriculum also in Spanish in your community, let me know. We can hook you up with how we do that. We launched in 4 schools in Central Texas. It's now 122 schools and growing. And we have this new awesome EV buyer's guide, ev.austinenergy.com, where you can get real-time inventory to ultimately increase the customer experience in buying and owning an electric vehicle. And then the last pillar is grid integration. We do have a vehicle to grid demonstration as part of the larger Austin Shines. We have a time of use pilot called EV360 for off-peak charging, as well as other DR and other grid integration strategies. And last slide is just if you want to follow up and do a deeper dive one-on-one on any of these programs, how you can launch them in your community, my email, I also post on LinkedIn, and some website information for your use there. So that's my intro. I'm Karl Popham, Manager of Electric Vehicles and Emerging Technologies. And you know, on the 10-year anniversary, I did have the honor to both co-found and lead that team in its 10-year to its current journey and its founding. And it's just been an amazing journey, a little over 16 years at Austin Energy, mostly from the technology space there.
Thank you, Karl. Cheers to 10 years. And I know watching all of these mobility sessions at ETS, there's so many different issues and initiatives for a utility to consider and pursue, but your strategy with the 5 pillars really organizes it very well. So thank you for that. And next we have Rob. Could you provide a bit of an introduction as well?
I'd be happy to, Laurel. Thank you. And first of all, it's a great pleasure to be here and honor to be here on this panel. Maybe I feel like a little bit of imposter in that, you know, Karl and Arlen have, I guess, well, they probably don't want to say how many years of experience, although I'm probably older than both of them. And I'm a relative newbie to the energy world. I've only been totally immersed in it for 2 years. But it's a wonderful and exciting place. I'm also doubly proud here because my youngest son graduated from UT Austin with a master's in technology commercialization, and I'm a great fan of the school, and as well as a great love of Austin. I am a GM Technical Fellow for Advanced Energy Services, and I basically assigned to work on the stuff that's sort of, some stuff that's really near and some stuff that's farther out, but all the work about electrification and sort of how we might bring it forward in innovative ways to speed up the energy transition in a way that's sort of sustainable, that's good for our customers, good for society, and good for us. And I basically have a long background in solving complex problems. I've done it sort of many different areas, global, domestic. But the last 2 years totally emerged in this and started off working on vehicle to grid integration and understanding its value, and that's driven and helped catalyze a lot of change in the company. I just want to share one slide and sort of on the, okay, so let me see. Okay. So has that come up? Yes, okay. So first of all, let me say, I'm not one to pass on corporate drivel, which most mission statements are at best. And so it's perhaps with an apology that I'm doing it, but a point I'm going to make is, so this is our vision to create a world, zero crashes, zero emissions, and zero congestion. And it is, what people don't get is that, in fact, the company has bet its life on zero emissions and on electrification. No joke, it is immense shift in capital and human resources to electrify the portfolio in a very, very rapid way. If we guess wrong, we're bankrupt, okay? And the government's not going to bail us out again. So we have really, bet the baby, bet everything that this is going to work. And we bet it was essentially still an unproven technology with the hope that the cost curve will cover and let it all work. When the company first did it and made it, they did it for a variety of very good and compelling reasons, both moral and business. But nobody really quite understood the full implications of what that meant. And we're kind of learning as we're going it, as are many of our fellow travelers and other, not only OEMs, but people that want to be OEMs. And that it's kind of a new world. So I was really struck, by both Arlen and Karl's comments, but especially sort of Arlen's comments about silos. And what we discovered that the way silos work within General Motors, they don't work anymore for what we need to do. And specifically what doesn't work is our relations with utilities. With the internal silos, how we relate to the people that relate to utilities and how GM relates to utilities. Both those things are now radically different than they were before we began electrification. And we hope it becomes a budding love. I think it'll be a budding love with a little elbow jostling, but for the most part, it really, really will be a budding love, but it's going to be brand new roles for everybody. Anyway, that's my intro.
Thank you, Rob. That's a great segue into our conversation, because you've talked about how GM used to operate kind of as a solo swimmer, which is an individual sport typically, and you've transitioned to play more basketball.
I use a metaphor of people running a swim race down lanes, and everybody wants to go as fast as they can within their lanes. And that was kind of the metaphor. And if you're running a race in a stable environment, in fact, that makes a tremendous amount of sense. That's not the right metaphor. The right metaphor now is maybe either a basketball game, or maybe a rugby scrum, maybe a rumble between gangs. I mean, and that is the right way to think about the world now. This idea that we're going to swim down our lanes and stick to those lanes and just get faster means we're just going to drown. That's not the way the world's going to work anymore. Mm-hmm. And I'd like to think it's more like a basketball game, and it was something that enjoys playing and everybody's going to win. And that truly is what I think is going to happen. Right. But it's, different rules, shifting, all that, much more fluid, much more dynamic.
Exactly. So today we're going to be talking about that basketball game. And to provide a bit more context, let's first address what's the history of this relationship between utilities and automakers. Karl, could you start with that question?
Sure. So under the guise of budding love, I guess so I've had the opportunity to speak to probably every major auto manufacturer over the years, over the 10 years. I can't think of one that I haven't at some level talked to. And it's generally around kind of three areas. One is just the car capabilities, the function of the car, battery chemistries, range, and potentially even connecting them with our community and customers. So Austin Energy serves about 1 million folks. We serve a lot of businesses. So it can be even connection on some fleet or just kind of what's going on in the Austin scene. The other thing we generally talk about is infrastructure. And this is a potential conflict where a lot of the OEMs, whether you're OEM charging infrastructure or car manufacturer, has the premise faster is better. It's almost part of their culture and DNA. And at the utility perspective, I always recommend right sizing. A lot of focus on public infrastructure, but here in Austin and also nationally, 85% of charging all happens at home. And about a half of that is plugged into a level 1 outlet, which everyone calls an outlet. And so you have some very low cost, ubiquitous solutions that work for a good chunk of people. So when you're looking at DC fast infrastructure, that's $100,000 per port asset versus a level 1, which is generally free, or if you're building out new, $100. And then level 2 can run $1,000 to a few thousand per port. It's about right sizing what the application and what the need is. I'm also always pushing for open standards. And I think for DC fast, CCS is the clear winner on the open standard. And I truly try to shy away, push back of more proprietary networks. The largest network in the US is also proprietary. It's the Tesla network. Now they've made claims probably to capture some of the infrastructure plan funds that they're going to be moving to an open architecture and let everyone charge there. But you saw the success of that. So you even had Rivian, I'm very excited about their product, announce, oh, we're going to have our own proprietary DC fast network at national parks and whatnot. We just need to get out of that proprietary mindset, and shame on us if we let a driver, an EV driver, stranded, right outside a proprietary network when that's, what they need. And I guess the third conversation is about vehicle to grid or vehicle to home. So when EVs first came out, every EV that I was aware of had some sort of warranty disclaimer. If you discharge your battery for anything else but spinning wheels, you may void your warranty. And we're now seeing that rapidly changing. The first big push I saw, I did get to go and speak to the Nissan Global folks in Tokyo, and they did a counter visit here. And they were the first one to announce, starting with their 2019 vehicle, they were going to remove vehicle to grid as any kind of warranty infraction, because they realized from the utility what it actually means. 14 to 16 events, 20 to 30% of your battery. And they're calculating based on 3,700 deep cycles for the warranty. So it was just noise. Like, of course, that's no brainer. That's more value we can bring to utilities and our customers. And if you look at what's happening with the Ford F-150 Lightning, if you go to their webpage, the very first feature that they post is power your home during a storm, 3 to 10 days. And the picture they show is a house mockingly with like porch lights and completely lit up, and the whole neighborhood dark because they plugged their truck into their home. And then the second feature they list is power your work site. So you're already seeing it as a competitive advantage of having these huge battery packs on wheels and what they can do both from a vehicle to X application. And then there's a lot of opportunities for utilities to basically capture that momentum.
Mm-hmm. Thank you, Karl. You hit on so many great points, and I'm sure we'll come back to many of them as we keep talking. But I'd like to ask Arlen a question of why should utilities in the auto industry take this relationship seriously and commit? I know you've been in talks with utility and auto industry recently, so if you could share a story about that.
Sorry, I was on mute. I think the evolution is interesting because when I started working on the CMC a couple of years ago, and I had the opportunity to meet with a top 10 auto supplier in Canada, and I met with their CTO and their CFO. And the first question just a little over 2 years ago was, okay, you're a utility guy. Why do you care? Because all they saw was, well, of course you're so happy because it's just increased sales for you. No matter what we do, you're going to make more money because you're going to be selling power. And it was, Karl talked about the infrastructure a little bit. And really, when we did the analysis for SMUD, and we're a relatively small utility, about the same size as Austin, and over 20 years, if we didn't do something around infrastructure to manage it appropriately, it was going to cost us and our consumers $3 billion is what we estimated with unmanaged charging. That's just one of the potential ripples out of it. And when we looked at it, if we can do some pretty substantial managed charging that meets the needs of the automaker, as well as meets consumers' needs, that cost dropped to $600 million. That is a huge delta. And when you think about it, the lower the cost of energy is, of electricity is, that's better for automakers because it makes the car more competitive when you look at the life cycle costs of the automobile. So just in 2 short years, those conversations have totally changed and people get it. So I think there's been great education and I think Karl alluded to the education he's been doing it with automakers, and it's really sticking. So this is a sea change, this transformation of the mobility sector. This is a sea change. It's going to have immense societal impacts. We run the risk of leaving people behind, like other technology things. We can't afford to do that from a social justice issue. We all have a stake in making this successful. If the automakers are successful and the utilities are successful and the auto suppliers and the tech companies and our consumers, which we share, by the way, are successful in this, then that's going to be a huge win for society. That's why I think that it's going to be real, because we all at this point, I think, recognize now it's not going to be an easy road because, there's a piece of the pie that comes with this and everybody's trying to figure out what that appropriate slice of the pie is. There's revenues associated with it. There's opportunities associated with it. There's costs associated with it. How are you going to share data? But there's an acknowledgement now that these issues are super complex and that they're overlapping. And what you really want to do is figure out, how do you optimize the solutions to these questions we have to struggle with in order to make this successful, in order to bring about the change that we all know needs to happen. And it needs to happen faster than any of us, faster than it is happening. Let's put it that way.
Exactly. And one of those technologies that both the utility and auto industry have to work together on to implement is V2G. So what do you see as the requirements for this technology to be implemented to its greatest potential from the auto industry and utility side? Rob, could you start?
Sure, I'd be happy to. I'm gonna share a slide. So it's hard to answer that question with any kind of clarity without some understanding of sort of the energy flows. And because, like a lot of you have been in energy for a long time and you get this intuitively, but I needed to explain it to my lords and masters in the auto business about what this is and what it was about, because they basically had no clue. And I was able to explain it to them to the extent I was able to explain it to myself, because I was just like a step ahead of them. So I kind of understood what they understood, because that was basically me. So how would I explain it to myself clearly? So began with this sort of simple diagram that just outlines the energy flows under today and tomorrow. And I guess I don't want to belabor this very much, but it's basically you have load comes from the grid. The grid is you have power providers from various energy types. The load goes in through a little meter, goes to a panel in the house. Then it either goes into the house itself, goes to an EVSC, or maybe directly into the car. And it also then goes to do appliances like in this heating and cooling. And here we have a little toaster. And so very straightforward energy flow. In this new world, energy will come out of the car, back through some panel, back through probably an EVSE as we call it, go into the panel, and then some will go to the home, and then some will go back out into the grid through a panel to an aggregator function, because nobody's going to be able to sell, no individual house will be able to sell. And so what this does is break down sort of where the value components are and where it comes from. The largest by far is this V to G to V to H, the value to, and this mostly all goes to the owner of the vehicle. This is the biggest size of the pie, okay? There's a piece on load aggregation. There's a potential for carbon credits, because if you do this right, it can reduce greenhouse gas emissions. And there's a load management, or this is what V1G, the world we're in today, the ability to essentially curtail resources, curtail consumption. And so this was the way to then dissect, okay, what is necessary to enable it? Okay, so that brings me to slide 2. And this is why the world gets really much more complicated, okay? Because it is a set of very different things. You might as well start up here. In order for this to work, either V1G or V2G, it has to be really easy for the customer. No customer is going to type in their utility rates, right? Or the utility tariffs. Nobody has a clue how to read the utility bill, except for maybe the people in this room. All right. But I guarantee it, your spouses don't. I shouldn't say that. Maybe your spouse is an electrical engineer. I mean no disrespect. For most people, no clue. It has to be as easy as one-click shopping. And it has to be integrated into the apps that people use to control their EVs, okay? If that doesn't happen, this ain't going to happen, okay? Then there's this little box up here on the wall, and it looks like a little discrete box, and it's just the box through which the energy flows. We call it an EVSE. In order for V to G to happen, this has to be affordable and much more affordable than it is today. It must be much lower in price, okay? Probably a fifth of the price of what you would do if you were buying an open system, okay? So it has to be smart and has to be affordable. There are none on the market. Honda does have a design. And then on the vehicle, you need a bidirectional, you need a pipe out of the vehicle, okay? Those are not currently on the vehicles. You need an inverter. Either you take DC out and invert here, or you invert it in the vehicle. Okay. And then in order to come out, you're going to need to have this aggregator, which doesn't currently exist. Okay. I mean, there are people that have tried it, okay? But it has to be scalable, high volume, integrates with UX, utilities, and the energy markets. This function does not exist. The big barrier, the hugest barrier is the regulatory environment. All this other stuff can happen technically and can happen reasonably quickly. But the regulations that enable it across the complexity of the utility markets between the not only different balancing authorities, but within the balancing authorities and the 3,000 utilities and all that jazz, that's the biggest barrier that we see to making this happen. So this is kind of helped us think about how should we architect our solutions and where our resources should go. And one of the reasons now relations with utilities are so important. We can't do this without utilities. We can't do it adversarially. We can only do this with utilities. And there's still going to be some competition for the control of the customer and all that jazz. But for the most part, it's going to be how do we share this to make it all happen? Sorry if that was a little long-winded, but I wanted to give it's a really important question, and I don't think you can begin to understand it until you kind of break it down into these parts.
Absolutely. Thank you, Rob. Arlen, Karl, I was wondering if you could share your story about your visit to Nissan and what they were worried about demand response and V2G, specifically with the battery warranty. and the misconception around that?
Certainly. And so every EV is going to have a warranty to it. And typically they're pegged at 60,000 miles, 80, 100,000 miles, whatever. And since the number one part of an EV is the battery, it's about deep cycles of the battery. And so that there's reasons why Tesla during a storm can all of a sudden give you 60 more miles of range, because they allow you to access the full battery. So it artificially limits the amount of deep cycles you can do just by the nature of the software to allow that amount of discharges and range. And so once they saw what a demand response program looks like, so here in Austin, Texas, on the ERCOT market, we chase something called 4CP, 4 critical peaks. So that's about 14 times a year. As much power as we can either not consume or ideally give back to the grid saves us ultimately on our transmission charges, or how the 4CP is calculated. So that's the passive ancillary market. So once they realize they're calculating based on 3,700 deep cycles, and we're talking 14 times a year, a 20% cycle, it didn't even register as an issue. So that's once they started realizing it's not about doing deep cycles every day. And then what we found so we used the Nissan Leaf as part of our vehicle to grid demonstration of the larger Austin Shines virtual power plant ecosystem, which is mostly stationary storage, big grid stuff, commercial stuff, residential stuff. To Rob's point, we use third-party aggregators. We use direct utility controls and created something called the DERO, the DER optimizer, as well as autonomous fire and forget. So we wanted to understand all the business models, all the different players and the different tiers of customer. And so you can read 500 pages of white paper. If you go to pluginaustin.com, that will eventually get you to our white papers. I'll give you the quick cliff notes on V2G and what we learned from it. One, technically it works just fine. It's super responsive. It does everything what we wanted to do. And for our vehicle to grid, we put it under the umbrella of our residential customer aggregator, which was provided by Pecan Street. But the business value isn't there yet. Once the commercially available bi-directional, so we used a bi-directional 10 kW flow system. At that time was almost the same cost as a Nissan Leaf. So already you're just way behind the curve. Two, that system was a little loud for residential use. It was right on the borderline of decibel levels. It's about the size of a refrigerator, so just kind of bulk. So just things we didn't like about it. But also we didn't see the market for it yet. So when I cut all that fluff away, here's what we've learned is V2G is not ready now for prime time, especially in the residential space. It's just not ready. We need to see some drastically reduced cost curves. We think the early winners will be what like Ford F1 Lightning and others are saying, power your home, power your workspace. Fantastic application. We also see real potential for fleets because they have much more control of a much larger aggregator. So the old adage of a school bus fleet, which is heavily underutilized during the summer, that's when Texas utilities need to do it the most. A really good business case around something like that because batteries are much more bigger and much more predictable. So, but what we also find, we also have strategies around incorporating what's sometimes referred as V1G. So that's incorporating electric vehicles as a demand response asset. So we already have over 100,000 plus air conditioning thermostats we control, and that's typically what Sunbelt utilities do. They curtail air conditioning load. We've also done pilots with the help of ARPA-E and others of putting EVs under that same kind of system. And here's what we found there. You can get about 80% of the value when we're looking at 4CP and other markets just on managing the charge, shaping the curve. And what we also find is customers are so much more willing to shape their EV charging than they are air conditioners. Air conditioners, typically people get 1 degree warm, they will what we call opt out and turn it back down and stay cool. And when we ran our pilot, we ran it both with air conditioners and EVs. We got the expected number of opt-outs for the air conditioners. We had 0.0 opt-outs for the EVs, because as long as it's ready in the morning, that's typically the behavior. And our time of use pilot, EV360, which has 100 pilot participants, very, very efficiency, high efficacy on pushing people off load. And how it's done is it's $30 a month, all you can charge at home, and 24/7 of all you can charge on the public network. So that's your total bill, as long as you don't charge during peak. If you charge any of those times, your energy is 0.00 cents. If you charge during peak, it's 41 cents, so quite punitive. And what we found with the 100, we found it works 100% of the time with 99% of the participants. Though there's one guy out there who just doesn't care out of 100. So that's not too bad. So it's more about a tiered strategy. I think it's less about discharging from the utilities perspective at this time. It's more about managed charging, so demand response, and that's something utilities are generally very good and we understand how to do. And then from a residential, hey, why not, since you're buying this truck anyway, might as well make it your backup generator. And here in Texas, that's resonating very strongly. There's a lot of demand for that F-150, and they realize it, and that's why they're promoting all this generation ability or backup generator of these huge battery packs.
Right on. Do you ever see net metering laws which require utilities to pay people for the solar on their roofs? Do you ever see net metering laws including vehicles?
It seems a logical step. So for example, our solar tariff, we do value of solar, which is a little different than net metering. Net metering just turns the meter backwards. And why we don't like that is, one, it gives more money to people who use more energy in a tiered utility. So Austin Energy is a tier, the more you use, the more it costs. Most California utilities are like that. That promotes efficiency. But we use a value of solar to level the playing field. For every kilowatt hour you give back, I think the latest is 11.2 cents. So it looks at the value of the energy, but as well as savings in transmission, distribution, climate goals, and it stacks this value stack. So we pioneered, maybe a strong word. We are an early adopter of value of solar. So it might be a value of EV charging or net metering. I think net metering in a lot of ways is a little rudimentary. I think value of can be capture more of the benefit and be more of an even playing field with a lot of different customers. But yeah, that seems to be where we're going. And smart policy, whether it's ancillary services in your grid operator or state or even federal policy, kind of all come together to, once again, to my panelists' points, is it creates an ecosystem to do anything. We don't do anything by ourselves, my little team here. It's all about collaborating with others, figuring it out, and then coming and launching something that's kind of what we look for always as a win-win.
Mm-hmm. Exactly, creating the win-win situation.
I think Arlen has some comments, but I muted him. So let me unmute you, Arlen. Okay, I unmuted you. Go ahead.
No, I'm just going to provide maybe a slightly different take from the California perspective. The net metering in California for solar was primarily based on wanting to promote an industry that created carbon-free energy. It's a little different if you're talking about a net metering equivalent for discharging the car back to the grid, because you don't know what that primary source of energy was. So if, you know, what time of the day it was charged matters from a carbon intensity standpoint. So there might be a few other things to think about. The other thing I would say is just to add to the kind of the customer value. If you look at SMUD as an example and several of the large IOUs, we've moved towards time of use pricing. So at SMUD, 5 to 8, Monday through Friday during the summer, really expensive if you're going to use energy. So I think there's another value stream to consumers potentially in using the vehicle at some point in order to be able to run your air conditioning when it's 105 in Sacramento in, you know, on the 3rd of August or something. So that's just one more value stream I think that's out there potentially.
And I think from a big picture, you do have to look regionally. Sorry, Rob, is what is California addressing and what's Texas? So we both produce pretty close to the same amount of renewable energy. Last time I looked, it was 22, 24 gigawatts respectively, but California is a solar state and we're a wind state. So California is trying to address the duck curve and how to address that with these different programs. We have potential a lot of excess capacity tonight, especially how West Texas wind blows in the CREZ zones. So that's just a completely different framework. Also, when you looked at the value of, you have to look at what's the value of the electricity. California has about twice the cost of the kilowatt hour energy charge in Texas on average, 10 versus 20 cents give or take. And so in some ways, California has an advantage because the value of their stored energy is worth more than in Texas with its lower cost energy. So I think it's very important to have, at the very least, a regional approach to understanding your solution, like GM when they come in, and what is the larger policy of that region based on those kind of type factors. And then as even how the grid is operated. ERCOT here in Texas, we operate kind of uniquely as a special little snowflake versus the Eastern and Western US grids. And understanding those nuances is how you develop where that win-win is and how you can take this great amount of storage that's coming into our service territories. The projections show 80% of all battery storage is going to have wheels attached to it. So it's not stationary storage, it's not personal device. So as utility, if you don't have a strategy to capture that 80% of energy storage systems in your territory, that is what the EV market is. You're just really not capturing, I think, the opportunity there. And Rob, we saw your hand.
A quick comment. So usually these panels are more fun if the panelists disagree with each other and start to fight. But I agree with everything you've both said completely. So I don't have any, so not only am I not going to fight, I'm going to sort of just emphasize. First of all, Karl, your comments on the time in which the applications we write, we don't see V2G happening until really starting roll in mid-decade to 2030. The first applications are going to be resiliency and vehicle to home and vehicle to load, to use the jargon of the industry. That's going to happen, I think, very, very quickly, as we see with Ford and as you'll see on GM products and other OEMs. And that's going to be a very compelling application and a relatively easy one to implement. We don't also see net metering happening as a part of the value for V2G. We just don't think it's going to be applied for the reasons that were said. And also this issue about how things are different locally, both because of time of use rates, different rate structures, different emission factors, different types of renewable energy, different load shapes. Completely agree. It's going to have to be a very localized solutions. So, I'm sorry I have to say it. I agree completely.
Very well said. And aside from just electric vehicles, we're seeing the auto industry emerge into the energy space in other ways, such as with Tesla's solar and batteries that they're offering. So this year, GM also just launched an exciting energy project that offers Texans with a GM vehicle access to cheap and clean energy. This was launched, I think, a few months ago. So Rob, it would be really great to hear the backstory of this new project and how it's doing now.
Sure, I would be happy to just spend a minute or two on this. So this was a kind of a really fun and exciting sort of what we call a reconnaissance in force into energy services. And the idea is, how can we speed up the energy transition more generally for not just the use of our product, but for our customers. And we realized there's something that we can do right away. And we decided to do an experiment in Texas. And so what it is that households in Texas and their permitted areas and within ERCOT who own any kind of GM vehicle, internal combustion or not, are offered really quite inexpensive green energy. And this is in partnership with Shell. If you have EVs, you get free charging at night. Okay. It is an interesting application for a couple of reasons. It's not commercially terribly interesting, but it's a very interesting way of thinking about how we might look at customers differently and how they might look at GM differently. And what it does is it lets sort of, if you will, the mass market go green and help them go green. So it's not just with all due respect to Tesla, which is an incredibly admirable company. It's not for people whose second choices are Porsches. It's for our Chevrolet owners, okay? is for people that own Chevrolet pickups, okay? They can get green energy, and a lot of those people now really care. By the way, there's been a sea change in how much people care about this. So 5 years ago, 10 years ago, there was a large constituency that hated this stuff, and it's about the same size that would pay for it. Now, probably half the population really care about it and willing to pay, and the part that's dismissive has gone way down, but it needs to be made easy. And so it's a way of making sustainability easy for our most important customer base. And then for our EV customers, it gets them used to the idea of charging off peak and gives them an incentive. And so that hopefully those behaviors kind of become ingrained. For suppliers, we have a similar program, and it is to help. GM has something like 500 suppliers in Texas. We have about 400,000 ICE or EV vehicles. They have different, they're on different steps on the journey. Some are farther along than GM, many are kind of much farther behind, and it's to help them make that move. So we're in partnership with Shell, offering them cheap. Once again, sort of this pricing is more complicated for businesses because each one's individual. We're going to subsidize at least the first move to green with really inexpensive energy. Another piece that's important about this is it's a total new way of doing business and how we need new partnerships. The partner here was Shell. And what we can offer Shell is essentially load. We can mobilize our customer base. We can reach out to them. We know them. We have relationships. And with our suppliers, we tell our suppliers, we think, hey, let's tell you about this. And our suppliers think this is a really good idea. That's not a hard sell. And we can tell our customers, hey, because you're part of the GM family, boom, this is something that you get. So then Shell is interested in saying, oh, we have our own ambitions to go green. Shell, as everybody in this call probably knows, just offloaded all their Permian assets, okay? The European oil majors are a lot different than the American oil majors and how they feel about the energy transition. It's like the Americans still don't believe it's gonna happen. The Europeans clearly do. We'll see who's right and who's wrong. Okay? And so we can have a sort of a commercial partnership that's aligned with both companies' long-term strategic vision of going to zero emissions and going green and becoming sustainable. And just one more piece and I'll shut up. It's an advantage that GM has that Tesla doesn't. So I'm just gonna say, we have a large installed base of customers, a really large installed base, and a very large installed base of suppliers. We have 50,000 suppliers, okay? If we can mobilize them to help incent them to move faster along this journey, we think there's a huge potential. So the average household consumes about 14,000 pounds of CO2 a year at national average emission factors. Average supplier, about 44 million pounds, okay? You move those guys over, it makes an impact. And we think there's sort of creative business models that we can use to do this. Anyway, that's where we're at. We're just starting, we'll see where it goes, and we're gonna roll it out. We are gonna roll it out nationally, and now we're figuring out how to do that.
Thank you, Rob, and everyone. It's been a pleasure talking to you today. And we've run over our time, but we have a surprise session right after this with two of my favorite energy thought leaders from SMUD. So please stay tuned for that with Nancy and Paul.
Okay.